How to graph y equals 1 over x, part 1 of 2. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. So let's first recall what we know about the reciprocal of a number. When x is equal to a half, 1 over a half, which is the reciprocal of a half, is equal to 2. And 1 half and 2 are reciprocals because their product is 1. And if you look at the equation y equals 1 over x, if you multiply both sides by x, it's equivalent to x times y equals 1, which shows that the product is 1. So let's go ahead and get to a graph paper. And we need to make a table. And this time we're going to use different values for x for our table for reasons that you'll see. So we'll start with 0, and I'm going to use 1, 2, 4, and 6. And then they're reciprocals, a half, a fourth, and a sixth. So when you try to take the reciprocal of 0, of course, that's undefined. For the rest of them, go ahead and complete the table. I'll pause the video, complete the table, and then resume when you're ready. All right, so here are the values that you should have received. If you need to press pause, do so. You'll notice that the product of x and y is always what number? 1, except for when we put in 0. So these are reciprocals. And so let's go ahead and plot these points. So 1, 1, 2 1/2, 4 1/4, 6 1/6, and then the other direction, 1/2, 2, 1/4, 4, and a 1/6, 6. Now we can also do the negative values, okay, which are the opposites of what we had before. And so it'll be basically the same points, but in the third quadrant. So let's go ahead and plot those. And then we'll go ahead and sketch the graph, connect the points. To finish the graph, we're going to have to look at end behavior. What's happening at the ends of each of the 4 parts of the axes. So as x gets very large in the positive direction, what is happening to the y value? For example, if x was 1,000, y would be 1 1,000th. So we'd go way out 1,000 and go up a little bit, 1 1,000th. And as x gets even larger than 1,000, what number does y get really, really close to but does not actually reach? And that number, of course, is 0, very close to 0. But keep in mind that it's always positive. So how we show that on the graph is we have this curve almost becoming like a line really close to the x-axis, but never ever touching it, really close. Looking at the other end, as x gets very, very small, negatively, that's way over here, this direction. What happens to the y value? So again, for example, if x was negative 1,000, y would be negative 1,000th. And so we would go way out there and negative 1,000th. And as it gets even smaller in that negative direction, what does y get really close to but does not actually reach? And again, it gets really close to 0, but in this case, always negative. And so we show that with this line getting really close to the x-axis, but a little bit below it. So as x gets very close to 0, that's this direction right here. What is happening to y? For example, if x is 1,000th, what is y? Well, the reciprocal of 1,000th is 1,000. And so we would plot 1,000th and go way up to 1,000. So as x gets even closer to 0, y gets even larger. And so how we show that on the graph is we have this line getting really close to the y-axis on the positive side, and we say that the curve is increasing without bound, or the y value is increasing without bound. And then on the other end, as x is very, very close to 0 but negative coming from this side, what's happening to the value for y? Try again, negative 1,000th. Y is going to be negative 1,000. And it gets even closer. Y gets even smaller and negative. And we show that this way. And we say that y is decreasing without bound. Press pause as needed. Where can you see hyperbolas in the world? So here's an image we found, thought you might find interesting. We encourage you to interact with the y equals 1 over x part 2 video in this series. And you'll be learning something on how to do the reciprocal dance and also something called asymptotes.